Thank you. So thanks, Daniel, for the great introduction, of course. And as he mentioned, I want to talk about building into Apple Intelligence ourselves today. And I want to structure this talk to be basically cover three things. First, I want to talk about the why. So why are we actually interested in doing this? Then I want to talk about the what. So what are we building in this talk? And then I want to talk about the how. And I want to preface this by saying I won't share much code in this talk because I just don't like this that much. But all the code that I created is in an open source repo that I will share a link with at the end of the talk. So you can just sit back, relax, and hopefully enjoy the talk. But let's start with why. So I'm not sure how many of you are aware of this, but every year Apple has a developer conference called WWDC. And in last year's edition, they introduced a feature which is called Apple Intelligence. And not only did they introduce it, but also they mentioned that it is going to be built into every operating system they have. It will have a lot of features, like everything will be powered by it. The new iPhones that are already released will be built from the ground up for Apple Intelligence, so it's everywhere, right? And I would say that the release of it has gone, well, I would say not ideal maybe, right? They introduced certain features already, but some of them are still missing, right? And this has different reasons. So one of them is that the EU has certain restrictions. So there's something called the AI Act, where they have certain regulations for providers to not allow them to share private data and sensitive data. And Apple has a good track record of being really privacy focused, but still they need to adhere to the rules. So the release process, like I said, has not been optimal, and video's out. No, it's going. And the news coverage around this has been interesting, to say the least. So there has been some very interesting articles that came out from the usual of, hey, something is rotten in the state of Cupertino. So basically it's the doomsday scenario, right? Apple is doomed. They will be gone in 2 years, like everything is terrible there. To the reaction of, I would say, a toddler who says like, okay, we're not getting it, but I actually didn't want it in the first place, right? So let's just keep it away anyways. Also, like, I mean, you got to take a dad joke if there is one, right? So I appreciate headlines like this always. But also, Tim Cook actually addressed this. And I mean, if Tim Cook personally addresses that certain features are delayed, I would say the problem is at least it's there, right? So we can safely say that it's not been a perfect release. But I think what always helps is to really calm down, right? Take a deep breath and just really think about this. Because do we really think that Apple is doomed? And the answer to that is no. I don't think they are, right? But has the release process been perfect? And to that, the answer is also no, right? But this actually got me thinking, because I'm a very smart guy. I'm not sure all of you know, but I'm a very smart guy, right? So I watched the keynote, and I watched all the talks about this. And I realized something, and I'm pretty sure I'm the first person to have realized this. Even Apple, I think, they might have missed this. So let's go on a little conspiracy theory here, and let's put on our tinfoil hats, and let's really closely look at Apple Intelligence. And if you look really closely, and you focus like a lot on this, and you rearrange some letters, you realize it actually says AI. And I mean, Apple Intelligence, that sounds complex, right? That sounds like, ooh, that's a lot to build, like a lot to integrate. But AI I mean, that's something that like we have heard of, right? It's been a buzzword quite a bit lately. But also it sounds a little bit like, yeah, we can actually manage to do something with that. So, for example, like there are tools such as ChatGPT. I think many of you have tried this, have used it, and have integrated this. There's also Claude, so there are alternatives, and there's GitHub Copilot and Cursor, which are great tools. And there's also Swift Assist. Well, somehow, right? I mean, you know, it's there, but I think it probably, like, let's keep it off that list for now. But when you look at all these tools and you think about like where in the process of creating a product they actually are, then you realize that they are actually in the development process. So we developers, we use that in our life to, well, improve the quality of our code maybe, to make our life easier. But this got me wondering, right? Because I'm not sure who knows these people. I'm pretty sure like nobody of you has ever met them, but you probably have heard horror stories, right? These are the users. These are the people who are actually using our products. So all the tools that I've shown you are using AI, but they're actually integrating AI into the development process, so they're helping us. But for me, that led to the question of how can we use AI to actually build valuable features for our users? And I really want to focus again, like I'm fine with using AI, and I mean it's a buzzword and everybody wants to use it, but like how can we actually use it to build features that benefit the people who in the end are using our product and actually are paying for it, if we like it or not, right? So I think this covers the why. So I think we can go on to the what. So we have a reason to build this, right? So the question is, what are we going to build? And the important thing is, like, we're not building the entire thing. So because there's a few reasons for that. And one is we don't have enough time. Like, I'm a single person. I can't build all of this myself, although I'm very smart. And also, there is the problem of scope. If you think about it, Apple Intelligence has been integrated into a lot of the products that Apple releases. And like this is just out of scope, so we can't build all of this. But also, thinking about where it is integrated, it uses very sensitive data, right? So it uses our personal connections. It uses messages we send to our loved ones or maybe other sensitive data. It has access to our photos. So this is a problem because we as developers don't get access to this naturally, and for good reason, right? But at least that shows that we can't build everything that Apple Intelligence does. If I were to build the entire thing, though, I think I have a pretty good idea what product I would use for this, and this is Stream. And coincidentally, like who would have thought, I'm actually working at Stream. So I want to just give a quick introduction about this. So we have SDKs. We have an SDK for chat, for video and audio calling. We have an SDK for activity feeds and for moderation. And we're not only on iOS, but also on many other platforms. And recently, we've also introduced features that include AI. And the cool thing is that we are offering quite a few UI packages and UI elements that you can introduce into your app. You can customize them to tailor them towards your needs. So it's really cool to work together. All our SDKs are open source, and they are free to get started. And also, quite a good news is that we're actually hiring. And we thought it would be an awesome idea to go to an iOS conference and announce that we're hiring for Android. And go. So, in case you're interested, let us know. You can talk to the Stream team, they're around here. But also, like, we constantly offer new jobs, so like, if you're interested, then please feel free to talk to one of us. But also, we are raffling away a mechanical keyboard. So we haven't had too many entries yet. There are some, but still, like if you want to join this, you still have a very good chance to get an awesome keyboard for free. It's actually at our booth, so you can check it out there. And there are two ways to join this. You can either sign up for a stream account and come to us and show this to us, or you can share a social post on either LinkedIn or Twitter with the hashtag #StreamIOSKonf. All right. Enough about Stream, because we're not going to use it for this project. But I really want to focus on three things when building this. So the first one is I want to get the UX of the features that I am building just right. I will not talk much about this because I don't want this talk to turn into something like a Swift UI best practice stuff. But also I want to use open source technology, which is a little bit more of a challenge because Apple traditionally has not been great or had not been too active in the open source community. That has changed a little bit, and I think the development is quite good at lately, but still they're not great at this. But also they tend to advertise that most of the things they're doing is actually happening on device. So I think it's quite easy to just call APIs such as ChatGPT and others to integrate, but it becomes quite a bit harder to do everything on device, really. All right, but this leaves us with one large problem. If we want to do AI on device, the problem is that models are actually really large. I'm not sure how interested you are in the topic, so let me quickly share a little bit about this. So for example, GPT-4 is a model that has 175 billion parameters. So this is 175 billion floating point numbers. That's quite a lot, right? Claude 3.5, we don't know because they're not disclosing it completely, but it's estimated to be even more than that. And Meta has been releasing a model that is even 405 billion parameters. So it's incredibly large. And you can't run this on device, but you really need to run this in a data center somewhere with GPUs that are very powerful. So that's a problem. Another problem is that GPT-4 and Claude, these are actually proprietary models. So they're not sharing how these models are built and how they work. So we can't really use that because we want to use open source. But the Llama 3.1 model, on the other hand, which is done by Meta, of all companies, is actually open source. So that's great for us, right? So the first problem is solved. We have open source technology that we can use. But still, it's models that are too large. So there's another interesting trend in the AI space, and that is that smaller models are becoming more and more powerful. And I just want to say again, there's a successor to the Llama 3.1 model, which is called Llama 3.2, which has only 3 billion parameters, which still sounds like crazy numbers, right? And we can't really imagine what that means. So let's compare this. The 405 billion parameter model is 850 gigabytes, right? So good luck integrating this into your app. I mean, like there's iPhones that have 1 terabyte of storage now, so you could argue, well, it's possible. But in order to run these models on device, you need to actually fit them into the RAM. So I'm not sure about you, but like neither my phone, nor my laptop, nor my iPad or anything, they have 850 gigabytes of RAM, right? So that's the problem. The 3 billion parameter model that I mentioned actually only has 1.8 gigabyte. Now this is still a lot, but we can fit this on our device and even into the RAM that we have. So this is great, right? And just to illustrate the difference between these two models, right, and the size of them, this is the 405 billion parameter one, and this is the 3 billion parameter model, right? Can you see it? Like it's not that large, right? So like it's a huge difference, right? So I think we can all see that, yes, that can fit on device. So we have solved the open source part, and we have solved the on-device part. So that's great. So let's look at what we're actually going to build. So the first feature that I want to build is writing tools. And if you look at that, we have a text, an input that we can give it, so the user can input a text, and they can actually tap on the button at the top right, which is the Apple Intelligence button, and they can ask to change up the text. They can, for example, select the proofread option, and the text will change. It will have this nice shimmer effect to switch up, and they can then rearrange it again, ask for different implementations, so different features or different tone of the text. So basically, they can do all the things that we are used to with the writing tool feature that is already released. The second feature is called Image Playground. I'm sure many of you have played around with this. And this is the app that or the feature that we have built in there. So first, it takes the model, it loads the model, and once it's ready, you can then enter a text. So for example, we're entering the text of dreamy place with clouds and sun converging into a calm atmosphere. I was really relaxed when I wrote this. So the model will take a while, and then it will spit out an image. And the image looks like this. We can then ask for a different style, so we can make it into a comic style, or we also have other styles to choose from. All right, this covers what we want to build. But now, probably the most important or the most interesting part is how are we actually going to do it? And for that, I don't know about you, but like when I think about how to solve a problem like this, sometimes the scope feels too large, right? It feels like this is too much that we want to build, and it's quite a complex problem to solve. So the good news for this is that we don't have to reinvent the wheel for this. So we actually have resources that we can use that help us to get this done. And Apple actually has some great tools that we can use to build AI and to use AI. And for example, there's ML Create, there's the Vision Framework, and there's also things like CoreML. I don't want to go into too much detail there, because there's going to be an incredibly great talk tomorrow that will cover most of this. So I don't want to take any of that away. But not only Apple, but also the open source community and other companies are providing great tools for us. For example, there's Swift Transformers, which Transformers is the underlying architecture of models like ChatGPT, which made these huge jumps in AI possible. And it's originally a Python package that you can use, but they also ported it to Swift, so we can now use this in Swift. Not all of it, but most of the things that are necessary for us. There's also a great company called Hugging Face, which you can think of as the open source comparison of GitHub when it comes to machine learning models. So they offer a hub where a lot of research companies or even popular companies like Apple or Meta or Google are sharing a lot of their open source models so that we can download them and use them in our products, which is quite great. And also there's a tool called MLX Swift. And I want to quickly dive deeper into this because we want to make heavy use of this. And if you ask yourself what MLX Swift is, the answer is quite simple. It's an open source port of MLX, which probably not many of you have heard of, right? But I don't think you need to know much about this. But the most important part of it is that this can be used to train and run models on device. And we don't care about the training part, so this is not part of the project that we're going to build, but we really care about the running part. So we're going to run the models on device, and MLX Swift is great because it is actually optimized for the GPU and the neural engine. So I thought. It actually is not supported on, like it doesn't support the neural engine, which is a shame, and I hope it's coming soon. And I hope that maybe at the next WWDC they will, Apple will announce something that supports this, because the neural engine is quite incredible. So on the A18 Pro, so the latest Apple chip, they can, like the neural engine can actually do 35 trillion operations per second. And I know like these are large numbers, right? But just for comparison, like I'm probably good for 0.2 operations per second. So this is incredibly fast, right? So if we can actually use something like this to run models, like this will be incredibly powerful, and the things it will enable us would be awesome. So let's hope that Apple will probably open this up a little bit more. But that's great, right? So we know that we can use Hugging Face now to get an open source model that we can then download and use MLX Swift in our application to run this model. So this is great, right? So we have solved the whole process of getting this done. So this sounds simple, right? Just download model, run it, and we're done. But actually, it's not that simple, right? So it involves quite a few steps. But the good thing, again, is do we have help for this? And the answer is yes, we do. Because we don't have to reinvent the wheel. Because, for example, like Apple is sharing a lot of great blog posts, for example, here on the Swift language website, stating that you can do on-device ML research with MLX and Swift. So they really describe their process, how they're using it internally. There's also a lot of introductory content. So there's a GitHub repository called MLX Intro. And there's even one called MLX Swift Examples, which have a few very nice examples that we can just look at and, how do you say, get inspired by, right? And even the community around this is great. So like I had a problem with getting one of their samples to run, which was completely my fault. But I asked someone from the team, so I opened an issue, and like within hours, they responded and were really helpful. So it's really a cool community, and they're really helpful. And also, like I mentioned before, there is the Hugging Face Hub, which gives us models to use. And if you can see this, there is even a community called CoreML projects. So these are models that have already been optimized to run on Apple's platforms. So it's great to have tools like this, and we can really leverage that and don't have to do everything from scratch. So let's get started with doing the writing tools then. I mentioned that this is not that simple, right? But if we leverage the tools that we have and that I just mentioned, then the process really comes down to first loading the model, creating the prompts. So we need to instruct the AI to do something for us. And lastly, we run the model, which sounds simple, right? So I want to start with loading the model, but for that we actually need a model, right? So I went to Hugging Face and I searched a little bit and I found one of the models that I mentioned earlier, so the 3 billion parameter model from Llama, which is 4-bit quantized, right? Which just means it's reduced in size, so the floating point numbers will just be reduced in numbers and in size, which loses precision a little bit, but it still has a very nice quality and it will just take less space on our devices. All right, so we can download that model, but how does that work? And actually, it's quite simple. So we have a load function, which takes 3 parameters. We have the hub, that's basically the Hugging Face hub, and access to that, so that we can access all these models that are out there. We have a configuration, which is a model configuration that we can customize this, but most of the times it's just fine with defaults. And then we get a progress handler to communicate the progress of the call. And then what we can do is we can prepare the model directory. So we want to save this model somewhere on our device. And we can hand in the hub, the configuration, the progress handler. We then create a model container, which is the object that we can later use to do predictions, which again we put in the hub, the directory, and the configuration, and we return this. Like I'm hiding away some of the complexity here. So for example, the prepare model directory function does quite some logic. But the good news is that most of that we can take from existing code. So for example, from the Swift examples repository, most of the code can be reused and just tailored slightly towards our use case. So this is great. All right, so we have loaded the model. Now we need to create the prompts. And as we can see here, we have a number of options that we want to support. So if we have a number of options, a great option is an enum. So we create an enum called writing tool options. And from that, we have all the cases, so proofread, rewrite, friendly tone, professional tone, and so on. And then we create an extension of this in enum, and we add a function called generate prompt, which takes the user text in, and then we can switch over the enum itself. And for the case proofread, we create the prompt of proofread the following text, correct any spelling, grammar, or punctuation errors without changing the meaning. Make sure the text reads smoothly and is error-free, and we append the user text. Of course, we can optimize this. This is just one prompt I came up with, so there's options to create even better results here. But this is quite easy to do, and we can do this for all the other options, so for the rewrite option and all the other cases as well. Okay, so we have created the prompts, we've loaded the model, but now we want to run the model. And for that, again, we can create a function. We call it run model. We give it the text that the user entered and the option that they selected. And what this will do now is it will use the model container with the load function that we just introduced. I'm just omitting the parameters for simplicity here. Then we create the messages that we want to hand to the AI, which is a message of the role user with the content of the prompt that we have just generated. And then we use a tokenizer to translate this message, which is a character, like strings or characters, into something that the AI can actually work with. And this is just numbers. So this sounds fancy, but basically it's just, let's take characters and put them into numbers so that the AI can process this. And then we use the model container to generate a result with the model and the tokenizer. We take the result, we decode it, so we take the numbers and put them back into characters and strings, and we assign it to the text input. And this is how this looks then. You've already seen this. We have a list of points, and we can actually change the tone of this to sound more friendly. We give this to our model, and it will generate a more friendly version of the bullet points that we have just entered. So this is quite nice. Then let's go to Image Playground, the second feature that we want to implement. And for this, the bad news is that this is more complex. Because for the writing tools, we had a text model, but for Image Playground, we actually need an image generation model. And there's a family of models that have become quite popular, which is called diffusion models, which are quite fascinating from a mathematical perspective. So basically, they start out with random noise in a picture, and they start creating shapes from it and tailor these shapes even further to the final result that we requested because of the knowledge it got during training. So it's a very fascinating thing, and feel free to Google this, how this works. But the good news is we don't need to know about anything of that. There are a few models for this. One is called DALL-E, which is from OpenAI. There's also Midjourney and Stable Diffusion. But if you remember for the text models, we saw a trend there, right? And we have the same trend here, which is that DALL-E and Midjourney are proprietary models. So these, again, are not shared with us, but they're hidden behind an API. So we can't really use that in our product because we don't want to use stuff like that. But the Stable Diffusion model, on the other hand, this is open source. So this is perfect for us. So naturally, what do? We go to Hugging Face and search for Stable Diffusion. And actually, Apple themselves are sharing an optimized model for this. So it's a CoreML optimized model called Stable Diffusion XL. And this is perfect for us, right? So we can integrate this into our app. And we've done this before. So there's just a few more steps that we need to follow. We need to add schedulers, pipelines, positive, negative prompts, PCA modulation, compute UI. So I think you get the point why I said it's not that simple. But the good news here is that similar to writing tools, we can leverage a lot of the features that Apple and others have shared with examples how to use Stable Diffusion in their apps. And if we use these tools and all the code that we have available already, it comes down to 3 steps again. And the first one is we need to load the model. Then we need to create prompts. And the third is we need to run the model. So through the help of this open source community and the examples that I have built, it becomes quite easy for us to get this done. And I don't want to go into detail, but this is then the result. I've shown this before. And we see it's possible to build something like this using what the community has built before and applying some new samples and principles to that. So I think it's quite incredible. Okay, so I've covered the how, but actually I lied to you. I want to make one more point, and this is how well does it actually work? So the demos look great, but maybe I've cheated a little bit. So let's talk about how well this actually works. And I want to talk about two things here. First is the developer experience, and second is the performance. And first, for the developer experience, it's kind of night and day, really. Because if you run into problems, the error messages can be quite confusing. Like, you will see a lot of numbers, you will see a lot of words that you don't understand. I mean, ChatGPT can be helpful. So when I paste the error message there, it can give us quite good explanations what might be going wrong. But still, we need to do changes, and it can be quite stressful to fix these bugs. But on the other hand, like I mentioned, the community around this is really good. So I mentioned this, I had an issue. I was opening up an issue in the GitHub repo, and someone responded very quickly, and they were really nice and helpful. And there are great resources out there, which is really helpful for us. All right, so the developer experience, I would say it's okay. But then let's talk about model size. I already told you that the 3 billion parameter text model is 1.8 gigabyte, which, well, we can download this. It takes a while, right? But the stable diffusion model is 3 gigabyte already. So it's still okay, I think, to download 3 gigabytes at times. But at least we need to notify our users and make sure that nothing goes wrong and handle all the error cases there. And also, what I noticed while running this is that 3 gigabyte in memory for an app actually leads to crashes sometimes. So there's ways around this. So we can request to have more RAM available for our app because it's a very memory-intensive app, but still you can run into problems. So I don't think it's an ideal solution yet. I want to talk about the initialization process. So we have downloaded the model, but then it's on our disk, so then we need to initialize it and load it into memory, actually. And the 3 billion parameter model actually took 1 second. So that's fine, right? We show a loading spinner, and we're done. The stable diffusion model that I used is actually taking 3 minutes to initialize. So after downloading 3 gigabytes of data, it takes 3 minutes to initialize. And yeah, we can work around that by trying to entertain our users while this initialization is happening, but still, I don't think it's a very sustainable thing to do this, really, right? So this is a problem. And then for the generation phase, I showed you the 3 billion parameter text model, which was actually happening in real time. So I didn't speed up anything. I didn't cheat there. And it actually created 30 tokens per second. And you can think of a token roughly like a word. So I think this is okay. Like the experience for the user is quite good there. For the stable diffusion model, on the other hand, generating one image actually takes 25 seconds, roughly, right? And this is using the latest iPhone. So on older models, this will take even longer. And you know, it's not a problem per se, because like you can clearly communicate this, but still it's not that fast, right? So we would need to at least work our way around this a little bit. So what can we actually do about this, right? So one solution is that we can use different models, right? The ones I used are probably not the best ones for this use case. It's just the ones that I have found. But if you're an expert in that, you probably find better models. And actually, I think it was 1 week ago, Apple even shared a demo of a new model that they created, and I want to show you a demo of this that I recorded yesterday. So this is a model running on device. It's called Fast VLM, and what it does is it actually understands what is in an image in real time. So what you can do is you can just point it somewhere and give it a prompt. I did describe the image in English, and it is doing quite a good job. It has some delay, yes, but I think like the speed and the quality of it is really good. It's not open source yet, so like we can't use it for the use case that I just suggested, but at least we see that something is happening, and Apple has actually been sharing their process more and more, which for us I think is a great development. All right, so we have different models that we can use. There's probably also a lot of optimizations that we can apply, because I'm not an expert in this, right? I basically just Googled my way through this, so I think there's probably a lot of great optimizations to do for this. But I think in the end it comes down to having the right balance of powerful models that are larger but will give us better results compared to smaller models that might be faster and easier to download and store on the device, but also the quality will not be on par with these bigger models. But just to look back, so I think we quite succeeded with getting the UX quite similar to the tooling that Apple provides. We used open source technology throughout the process, so that went great. And finally, also, we did everything on device. So I think we achieved that. And with that, we really respect the user's privacy. So I'm pretty sure Apple would be really proud of us for doing this. So this is all I wanted to talk about today. So thank you for listening. And if you want to follow me, you will find me on X and all the other social networks, and you can find the code in this repository here. And that's it. Thanks.